I do believe that those sectors that are indicated are among the most representative, and I think it's very necessary to distinguish when you address, in a social science perspective, advanced technologies, reality from science fiction. So it's very necessary to be accurate about what is real and what is out there, and what instead lays in the realm of literature, science fiction, and depictions. And so it is essential to focus on those technologies that are already existing and diffused. To some extent, however, having in mind that any approach to understand reality in a social science perspective needs to anticipate what we could call the second bounce of the ball, with a tennis analogy. So trying to second guess where technological development is headed.
Investigation we did about the social uptake of robots in Europe, we can see that there are huge differences between sectors. I mean, I always start in saying that the industry has a long history and experience of using robots and a well-developed concept of safety and how to collaborate with robots, while in other fields like social uptake in the public domain is not so well developed. And also, how do we know this? How do we know this? I mean, if the European Commission want to increase a relevant and sustainable impact of robots in the public domain, they need to make investments in the public domain, in the social sectors.
I think in my sector, I mean, what I feel has been really important is in the health sector, in healthcare, robots in the healthcare. What we have seen in the latest years are litigations on patents protecting surgical robots, basically. So this is a sector where companies have litigated, trying to protect their technology, protected by patents, and such litigations have been quite high profile. I just wanted to flag this up because in my sector, in the IP, this is quite important.
According to what we did in Work Package 1, it is possible to understand that most of the companies working in interactive robotic fields are mainly located in three market domains that are healthcare, manufacturing, and consumer robots. So another aspect that could be taken into account for understanding the different domains is the level of maturity.
From a historic perspective, robots have been used in manufacturing or in industrial applications for a long time now. So they are well defined in standardization, or industrial robots are well defined. And it's increasing in the medical and healthcare domain. But Roberto just mentioned that those are quite some of the state of the art is already defined, and for some other categories or domains like agriculture or also logistics, there's not much done already in standardization on it.
Also, robots could have a role in the monitoring of different types of environments to support also the climate science, all the monitoring aspects of the weather conditions and the impact of the industry in assessing the environmental compliance. So I think this is becoming and will become a big domain in the landscape of robotics.
What I see is that robotics should face the challenge to deal with cross-sectoral issues, not only focusing exclusively in certain domains. I feel that there is a need to do some mainstreaming of the Sustainable Development Goals all over the sectors, and try to introduce ESG criteria and thinking on how facilitate reporting on financial and non-financial aspects, caring for good governance, and taking into account society as a whole, and not only focusing on the relation between a machine and a person. And in this sense, life cycle approaches as proposed by the new plan in the EU on circular economy will call for a better understanding of impacts on environment. And here, after COVID-19, robotics has been accelerated, and this is a good occasion to try to find with statistics and real data how to move forward.
Natural events like typhoons, windstorms, or hurricanes are happening more often than in the past, no? So maybe one sector that could be very important and strategic for the future is robotics for emergency, that could be very useful, no, in these disaster events. So maybe this could be an interesting point to add in the future robotics development.
In many application areas, the existing regulation could become a barrier to adoption and deployment. And this is more visible, I think, in those that are in close interaction, those applications of robots that are in close interaction with people, either in a digital or in a physical manner, or where, for instance, AI and robotic technologies are operating in terms of safety and privacy critical environments. So I don't know if it would be helpful to try to distinguish those operating conditions in which you have critical safety and privacy issues, which will have an impact on the possible exploitation and standardization of this.
Just from a standardization point of view, also in every standard, it's always like the technology is described, and then also the operating environment of this technology. So it's always somehow included also in a standard where or on what operating environment the standard is focusing on.
Well, from a legal perspective, the operating environment is always a way to try to center the regulation applicable, but up to now the main focus has been to pay attention to risks. And now if we move to responsible research and innovation, we should also try to consider which opportunities are open to robotics. So instead of having a reactive regulation, we should care for a proactive regulation and try to find out which are the very basic principles that could be adopted, introducing different layers of protection depending on the environment.
We've identified in INBOTS a couple of standardization potentials and challenges, and especially the consortium itself identified a couple of potentials. For example, that test methods and performance criteria are not that well defined when it comes to wearable devices. Therefore, we also initiated the development of self-worship agreement. So we already took some actions there. And we also found out that when it comes to robotic devices, they also is an increasing effort in including artificial intelligence in them, and therefore standardization efforts also need to increase in this section. And also, for example, when it comes to test methods for non-professionals, so other test methods basically where because those robotic devices are more and more used by people that are not familiar with them. So maybe test methods for people that have a non-professional background and so on could be considered. But those are only some examples. For more information, I would refer to this white paper that we developed. And when it comes to we also identified some general challenges in terms of standardization. We found out that companies face the challenge that it's difficult to identify hazards and standards and so on. And we therefore thought of that it might be helpful if something like a benchmarking database would be set up, basically where organizations describe their devices, their hazards that they found out for their devices.
Because robotics applications are so diverse one from the other, and today at European level we also like to discuss a lot about artificial intelligence, and to some extent, at least in a policy perspective, advanced robotics is seen as a subfield of artificial intelligence. I do believe that it is preferable to have a class of application by class of application approach. So we should not pursue a uniform body of regulation attempting to tackle all sorts of robotic applications unitarily. We simply cannot do that. Diversity is too broad, and we are much better off by understanding specificities, understanding differences.
I have to say that I can understand what you said, that it's not a good idea to have a uniform legal regulation, but I have difficulties to see how we can promote social uptake and equality in Europe without having a uniform social policy. So I would say that I can see several gaps from the social uptake point of view. One gap is that I mentioned before, that there is a lack of statistics, there's even a lack of joint policies in Europe. And we can also see from a workshop that we had in Madrid last year that companies are very interested in and willing to diversify their production. But they need to understand, get more knowledge on how to move into new markets, especially markets that are not so familiar, like care, for example. And here we also I agree that there's a big need of standardization.
The standardization is an essential piece of regulation. I have to say that overall the European legal system isn't doing very bad with respect to standardization. We have a solid approach to product certification and standardization. We have to investigate and understand very well the relationship between product safety regulation on the one hand and other bodies of European regulations such as liability rules. We have to understand the reciprocal functions and interactions. To some extent today there is an overlapping. Those hypotheses for overlapping should possibly be reconsidered, because in some cases, for instance, the functions of liability, that of providing ex-ante incentives towards preventing the accident, and those associated with exposed cost management, so imposing the cost upon the responsible party, should probably be disentangled, and standardization could play an essential role by taking over entirely the first task that is typically also attributed to liability rule, meaning that of providing correct incentives towards making high quality and reliable and safe products in the very first place. So standardization has a gigantic role to play with respect to technology regulation. It's an essential tool and should be used at European level, because standards influence the market. So it is preferable to have a European approach to standardization. However, we also need to be extremely cautious about what standardization can actually tackle. There are many relevant and very essential issues that have to do with fundamental rights of the individual, primarily human dignity, freedom of self-determination, that are often mirrored in ethical analysis, that are, however, hard to transpose into ethical standards. So we should not understand standards as the one-fits-all solution to address any issue with respect to advanced technologies.
We are focusing maybe our attention on technical standards, but there is also room for standards that could be better implemented and updated, like the one on corporate social responsibility, because in this field regulation is not mature yet, so we have to trust on the actors, the manufacturers, who are experts in the sector, but they should report with transparency and to try to create trust amongst the different stakeholders. And for that purpose, certification will sure make an impact.
By considering the overview that we carried out about the robotics companies working in specific sectors like wearable robots, humanoids, surgical robots and industrial collaborative robots, it is quite evident that for sure the main sector where the impact of the robotic technologies are mainly present are healthcare sector and for sure the automotive sector.
Well, the labor market is constantly changing, and nowadays we cannot predict how it will be impacted in the year to come. But what we know for sure is that if we want to keep as many as possible persons working in the different areas, we should try to help them with capacitation and technological training. This means that a lot of investment in education has to be made, and here the public funding and private funding should try to match the necessities that the population is experiencing, to try to avoid a robotics divide in the labor market, which at the end of the day comes at the expense of equality. And this is important because taxation could be used to signal the behaviors that are desirable in the market and for the companies to implement.
Educating professionals, workers, students in the use and understanding of robots is very important for the social acceptance and uptake of robotics at different levels in the society. And however, teaching and learning robotics is quite challenging because robotics is an interdisciplinary subject at the intersection between maths, physics, mechatronics, programming. So this is challenging, but at the same time, this interdisciplinarity of robotics is what makes robotics so fascinating for people of very different ages also. And for example, in schools, robotics is used to teach other STEM subjects. So this is what we found also within INBOTS, that actually there are more and more initiatives in schools to use robots as tools for teaching other subjects. And however, these initiatives are sometimes not very well structured, and the teaching programs are very different from country to country. When we talk about education, robotics education at the university level, we focused within INBOTS on highly accessible open resources available online. So we found that there are more and more resources of this type available online, and we think that these are good tools for students of different levels to integrate their knowledge. When it comes to educating in robotics in companies, usually each company decides how to train their workers, and there is not yet a unified approach for this.
Education is not only education in robotics is not only something related to schools, universities, and internal knowledge of the companies, but it is also important for convincing stakeholders.
In order to exploit the potential of interactive robots in the field of social uptake and among the general public, we need to take into account the practical context and the human experiences. I mean, we have to go from, we have a lot of good technology, promising technological applications that are ready, high up on the readiness scale, but it's not adopted. So that's a very, very important step.
Both robotics and artificial intelligence are actually umbrella terms that are used at policymaking level to refer to the broader spectrum of applications. So there are not two things that are deemed to be robots that are really alike. You can eventually identify classes of applications for robotic applications or AI-based systems alike. So in a social science perspective, it kind of makes sense to refer to advanced robotics as a subfield of artificial intelligence, with the fundamental caveat that none has a very strong value to define the object of the analysis, and that any relevant policymaking initiative and analysis or regulatory intervention should be much more specific and not attempt to address robotics or artificial intelligence unitarily.
The European Parliament is providing several definitions that we could take for the sake of clarity. In that sense, robotics means technologies that enable automatically controlled, reprogrammable, multi-purpose machines to perform actions in the physical world traditionally performed or initiated by human beings, including by way of artificial intelligence or related technologies. So here we often use the term artificial intelligence very broadly, and of course part of robots are having included artificial intelligence in their built-up procedures, but others still don't. So the situation for legal purposes should be accurately defined. And instead, if you have only AI and robots, you will need, of course, data, and big data is also a part important, because robots will create data and also capture data.